Welcome, my dear students. This is Ankit Sharma. I hope you all are safe at the time of coronavirus outbreak. So, first of all, congratulations to all of you. You are promoted to your next class, that is class 8th. Now, I request all the my dear students to don't go outside, be at home, follow the social distancing. Okay? All the best, better. Now, let's start our e-course of class 8th. So, let us start with chapter 1, that is matter. You have already studied that same chapter in class 7th also. There is that chapter name is matter and its composition. Now, let's come to the contents of that chapter. First of all, there's a brief introduction to the matter. Now, the second topic is states of matter and their explanation. Now, that third one is interconversion of states of matter. Now, fourth one is terms related to interconversion of states of matter. And last one is law of conservation of mass. Now, let's start with the introduction. As we know, anything that occupies space and has mass is matter. It includes that food we eat, the water we drink, the air we breathe, and even the book we read or the cell phone we are holding right now. Thus, all the things living and non-living things are matter. So, if we look around us, we see a number of things like stones, sand, clay, water, mineral, plants, animal, pens, books, etc. They overall are made up of different types of materials and are called matter in our general science. Now there is a common definition also. Anything that occupies space and has mass is matter. Now, matter have several states and its properties also. So now there are several properties, that is matter occupies space. So matter occupies space and the space occupied depend on its shape and size. The second property is matter has mass. Let us understand that property with the help of example. Let's assume that we have two balloons. Okay? These when two balloons of the same size are hanged on a beam balance, okay, or on a rod, then when two balloons of the same size are inflated equally and tied to a straight rod or a scale, the scale remains straight. When one of the balloon is deflected, the scale tilts toward the inflated balloon. That is because inflated balloon has more mass than deflected balloon. That simple means matter has mass, that air contains mass. Third one, matter can be detected by our sense. When we can feel all type of matter by our senses, such as by touching, smelling, etc. For an example, matter such as air may be invisible, but we can still feel its presence. Every time a strong wind blows, we feel it on our face and in our hairs also. Now, the fourth one is matter offer resistance. Here, the word resistance stands for an barrier. Barrier means जो अपने को आगे बढ़ने से रोकता है. Okay? So, it is difficult to swim against a strong current of wave. Similarly, one cannot easily walk through or during a storm or in a heavy rain. Okay? In that case, जब बारिश होती है और या फिर तेज हवाएं चलती है तो that air resist our body to move forward. तो वो हवा और पानी क्या करते हैं, अपनी बॉडी को आगे जाने से रोकते हैं. दैट्स वाई वी कैन से मैटर ऑफर्स रेजिस्टेंस. नाउ let's come to our next topic, states of matter. As we generally know, there are three states of matter: solid, liquid, and gases. In solid states, these, the matter or the substance, these are hard and have a definite shape. And in liquid, these are not hard and do not have a definite shape. These take the shape of the container they are put into. That means अगर हम किसी भी लिक्विड को किसी भी पॉट या फिर किसी भी ऐसी चीज़ के अंदर डालते हैं तो वो उसी चीज़ की शेप ले लेता है. ओके, दैट इज़ द प्रॉपर्टी ऑफ लिक्विड्स. नाउ द लास्ट वन इज गैसेस. they are they too are not hard and do not have a definite shape. These are also like liquids. अगर हम इनको भी किसी भी कंटेनर के अंदर डालते हैं तो उसके अंदर स्टोर हो जाते हैं, बट दे नॉट टेक द शेप ऑफ दैट कंटेनर और द pot. That is the difference between liquids and gases. Now let's understand the intermolecular space or force between solid, liquid, and gases. Now, as you know, what is the intermolecular force? The force between two particles, okay, that attract each other. That is known as intermolecular force. Now, first see the solid. In solid, intermolecular force is strong. This results in the particle being packed together tightly. And second one, that is liquid. Here intermolecular force is little bit weak in comparison with solids. So hence the particle of liquids are not packed tightly. And in gases there are no intermolecular force. There is only intermolecular space. That means they have a large space between one particle to another particle. That's why they are packed loosely. So now let's understand this solid, liquid, and gas substances. Now first is solid. In solids, particles are tightly or closely packed, as we seen in the intermolecular force structure. Now second point is the gaps between the particles are tiny and hence it is thought to compress them. So it is a very tough task for us to compress the metal or in a solid, okay, because there are less intermolecular space present between them. Third one, solid has a fixed shape and volume that we already know by our previous classes. Fourth one, due to its rigged nature, rigged means that is hard nature, that is solid nature. Particles in solid can only vibrate about their mean position and cannot move. So in that fourth point, that particles are only can vibrate in a metal or in a solid. They are not allowed to move like liquids. Liquid can flow but solid cannot flow. That's why the solids are only able to vibrate on their position, on their mean position, on their current positions. Now fifth point, force of attraction between particle is very strong. So that's why they are pegged tightly. Now there are several examples of solids like solid ice, sugar, rock, wood, and etc. Now there are general structure of solid, a solid cuboid. Now come to our next substance, that is liquid, that liquid state of matter. Now in a liquid state of matter, particles are less tightly packed as compared to solids. Liquid take the shape of the container in which they are kept. We already know that point. Now, third one. Liquids are difficult to compress as particles have less space between them to move. Yes, that is true. We can't compress liquid, but we can compress gases, okay, and then they will convert in the liquid form. Like nitrogen gas can be compressed in a liquid nitrogen. Fifth point is, sorry, fourth point is liquids have fixed volume but not fixed shape. That is true because they will take the shape of the container. Fifth point, the force of attraction between the particles is weak in comparison with solid. Sixth, example of a liquid state of matter. Now there are several examples and we already know from our daily life, our general life, water, milk, blood, coffee, etc. Okay, any mixture, any homogeneous and heterogeneous mixture, there is an also example of that liquids. Now let's come to our next, that is next state is gas. Now there is no intermolecular force between the particles of gases. In gases, particles are far apart from each other. Okay, they are only intermolecular space. Second point, force of attraction between the particles is negligible and they can move freely. So, gases have neither a fixed volume nor a fixed shape. Fourth point, the gaseous state has the highest compressibility as compared to solids and liquids. We know that only gases can condense or compress to the liquid form. Now there are some examples of such gases: air, helium, nitrogen, oxygen, carbon dioxide, and etc. Now, for there's a brief summary of the three states of matter. Now, the three states of matter can be represented by the following diagram, which describe all the properties or as discussed above. First, in solid. In solid, look, there are four particles. They are fixed on their mean position. Okay, they are not allowed to move. But in liquid, their particles are allowed to move in a random direction. Okay, so that's why liquids can flow and solids cannot flow. In gases, their particles are not fixed in a current position, so they are also allowed to flow in a random direction. Now let's discuss some general properties of different states of matter, which we have already studied in our class 7th. Now their general property. Now we are going to talk in reference with their mass, shape, volume, compressibility, fluidity, rigidity, diffusion, space between particles, and intermolecular force. Let's start. Now, you now you are seeing a comparison table. There are three states of matter: solid, liquid, and gases. First, in with reference with mass. Solids have definite shape, liquids have definite shape, and gases also have a definite shape. Sorry, definite mass. Now, with respect with shape, now liquids and gas acquire the shape of the container or the pot which in they are stored, but solid have a definite shape. With respect volume, solid and liquid have a definite volume, but gases does not have a definite volume. They have indefinite volume. And compressibility, solid and liquid are not compressible. Okay, but gases are highly compressible. Some time, liquids are compressible. Okay, but they are negligible. They are there are only 1% chances of compression. Now, fifth point is fluidity. That means if they can flow like water, so we know solids are not flow. They are, in that case, that is not possible. But in case of liquid, that liquid can flow, and also gases are also allowed to flow. Rigidity, that means how hard and how rough they are. Okay, so solids are very hard and liquids are less hard, less rigid in comparison with solid, and gases, they are not rigged. Now our seventh topic is diffusion. Now diffusion means spreading of the elements, spreading of the in the states of the matter in the different states. So spreading in case of metals or solids, the rate of diffusion is slow. In liquids, that rate of diffusion is fast. That gases, that is very fast. Now, in 8th point is space between the particles. So we have already studied the intermolecular space. So we can say solid, they are mostly tightly packed. Liquid, they are less closely packed, and gases, they are least closely packed. Intermolecular space, in a solid we have strong intermolecular phase or interparticle phase force. Now in liquids, slightly weaker in solids, but in gases that is negligible. Now we have studied some general properties of matter. Now there are some general terms in chemistry. We have to understand them to understand the topic interconversion of state of matter. First is melting point. So what is a melting point? The temperature at which a given material change from a solid to liquid, that is called a melting point. Freezing. Freezing point is the temperature at which liquid changes to solid. Sublimation. Sublimation is a process in which a solid is directly converted to the gaseous form. Vaporization. Vaporization is a conversion of liquid state in the gaseous state in water. It is called vaporization. Condensation. Condensation is the process by which water vapor in the air is changed into liquid water. Now, so here these are the definition of the melting point, freezing point, sublimation, vaporization and condensation. Now let's understand them again. What is melting point? The temperature at which a given material changes from a solid to a liquid or melt is called its melting point. Example, 0 degrees Celsius for any ice cube. Okay. Now, freezing point. Freezing point is the temperature at which liquid changes to solid. Freezing point of water is 0 degree Celsius. Sublimation. Sublimation is a transition of a substance directly from a solid to the gas phase without passing through the intermediate liquid phase. One example is camphor. Camphor means that कपूर. ओके जब भी हम कपूर की गोली को जलाते हैं तो वो क्या होता है, डायरेक्टली गैसेस में कन्वर्ट हो जाता है. वेपोराइजेशन. Conversion of liquid state in the gaseous state in water is called vaporization. Now, the condensation. Condensation is a process in which water vapor or the water droplets are converted to the liquid form. Is this process in the process by which water vapor in the air is changed into liquid water. Okay, so now there are some general definition of terms. Now let's study our next topic, that is interconversion of states of matter. Now as we can see in a diagram, okay, first we start from the solids, that is the solid. Now if we heat the solid, okay, so that will convert in liquid state, then by vaporization it will convert in gaseous state. Then again if we condense the gases, then it will again convert into liquid state. Okay, and if we freeze that liquid, okay, or if we make down the temperature of that liquid, okay, so that will again convert in solid. Okay, now there is an alternate or direct method to convert a solid into gases, that is sublimation. Okay, By sublimation, if we heat the solid, then it will directly convert to the gaseous form. And again, by reverse sublimation, that by the means of condensation, okay, or the reverse sublimation, we will convert the gas form to direct to the solid. Okay, now let's understand it. First, states of matter are inconvertible by applying heat and pressure to them. That means कि जो भी मैटर की स्टेट है वो इनकन्वर्टेबल और कन्वर्टेबल, मतलब कि वो कन्वर्ट हो सकती है कैसे, अगर उसको हीट और प्रेशर अप्लाई किया जाए. सेकेंड, when solids are heated, the inner molecular force of attraction between particles decrease and they convert into liquids. That means जब भी solids को heat किया जाता है तब वो liquids में convert हो जाते हैं. Okay, the intermolecular particles are lose their space. Third one, liquids on further heating converts into gases. As we already know, if we heat the liquid, then that will be get vaporized. Fourth one, gases are invisible, do not have a fixed shape and volume because intermolecular force of attraction becomes zero. As we already discussed, in gases there is 0% intermolecular force, that is only a intermolecular space. Okay, so that is the interconversion of states of matter. Now our next topic is law of conservation of mass. So it states that the law of conservation of mass states that the matter can neither be created or nor be destroyed in a chemical reaction. So that is the last topic of our chapter. So what is the law of conservation? The law of conservation of mass states that matter can neither be created or nor be destroyed in a chemical reaction, but it can be converted in one form to another form. Okay, now let's let's understand that law of conservation with the help of an example. Okay, first, in a combustion process means अगर हम किसी भी चीज़ को जलाते हैं. Okay, let's take a burning wood example. Burning of wood is a conservation of mass. How? That means जब भी हम लकड़ी को किसी को भी जलाते हैं, वुड को, then that wood will be converted into, as the burning of wood involve oxygen, carbon dioxide, water vapor and ashes. That means that reactant side is also equal to the product side. Okay, जो भी वुड के अंदर जो भी सब्सटेंस प्रेजेंट होते हैं वो एक स्टेट से, एक फॉर्म से एनर्जी की दूसरी फॉर्म में कन्वर्ट हो रहे हैं. ओके, नाउ लेट्स टेक अनदर एग्जांपल, मेकिंग ऑफ वाटर. कंसिडर दैट फॉर्मेशन ऑफ वाटर मॉलिक्यूल. हाइड्रोजन combines with oxygen to form an water molecule. Now at that second example, at reactant side we have 4 atoms of hydrogen and 2 atoms of oxygen. When they combine, they will make 2 molecule of water. Okay, we can see H2O here, 2 molecules of hydrogen and 1 is oxygen. So make the thing notice here. Now in the reactant side there is 4 atom of hydrogen, and in product side there is also 4 atom of hydrogen, and in reactant side there is 2 atoms of oxygen, and in product side there is 2 atoms of oxygen. That means so that is the law of conservation of mass. Okay, now this is your chapter number first. I hope you will get it. Thank you for paying your attention. Now I request all the students to make a separate notebook and note down whole presentation in your fair or in rough notebook. I will check that notebook when school get open.